In this video, we're going to be talking about the definition of a rational function and the notation that we would use in discussing that. Now, if we let p of x and q of x be polynomials where our q of x doesn't equal 0, then a function f is defined as the p of x divided by q of x. We call that a rational function. And what's important to note here is that the domain of a rational function is all real numbers excluding the real zeros of q of x. So for example, if we have 1 over x, which is our parent function, and we look at that factored form, we see that that can't be factored any lower. And so our domain is the set of x's where x can be anything except for 0. And in interval notation, that would mean from negative infinity to 0, with a union from 0 to infinity. If we look at a little bit tougher equation, such as our g of x here, that has a 5x squared in the numerator and 2x squared plus 5x minus 12 in the denominator, it's going to be easier to see that domain if we break that into factored form. Doing so gives us a denominator of 2x minus 3 times x plus 4. So we can see that x is not allowed to be 3 halves and x is not allowed to be negative 4. So our domain is going to be the set of x's such that x can be all real numbers except for 3 halves and negative 4. So in interval notation, we would have from negative infinity to negative 4, and then from negative 4 to 3 halves, and then from 3 halves to infinity. If we look at an equation such as k of x, which is x plus 3 divided by x squared plus 4, and we look at that factored form, we see that here, because the x is squared in the denominator, it doesn't matter if x is positive or negative. It's never going to be able to be a negative 4. Therefore, the denominator would never reach a 0. And so x can actually be any real number that it wants to be. Now, as we analyze rational functions, we want to be able to determine the behavior of the function as x approaches infinity or negative infinity, and as x approaches values for which the function is undefined. So let's take a look at some of the notation that we would want to use in that instance. So here, let's assume that we have a value that we want to go towards. So what does it mean if it says x arrow c to the plus? Like, what does that mean? Well, what that means, we're going to be looking at x as it approaches c from the right, but it will never get to c. So that plus sign means that we're looking at the right-hand side. So if we see something that says c to the negative, then that most likely means that x is going to approach c from the, that's right, the left-hand side. But notice that it will not actually equal c. And we have x approaches infinity, which means that x will increase without a bound. And x will approach negative infinity, which means that x will decrease without a bound. Let's just take a look at a little example to help us out with this. So consider f of x equals 1 over x. So that's going to be the equation that we're looking at right here. And so we can see that that's graphed in the blue line. So notice that as x is approaching negative infinity, right? So that means as x is going this direction, what is the y doing? And we see that our y value is approaching 0, but it's just approaching that 0. And we can see that a little bit better as we look here. As x is getting closer and closer and closer to negative infinity, we see that our y value is getting smaller and smaller and smaller. It's getting closer and closer to 0. Now, if we look over here, as x is approaching 0 from the right, so that means as we're coming in this direction towards the number 0, what is happening to our y value? And our y value is going up, right? It's getting up there. So again, as we approach 0 from the right-hand side, we can see that our x value is getting bigger and bigger and bigger, so closer to that infinity. as we approach 0 from the left-hand side, so again, that means that we're approaching 0 from this direction now, what's happening to this value right here? And it's going down. We can see that in our table, that as we get closer and closer to 0, but from the left, hence all the negative symbols, that our value is getting more and more negative. So it's approaching that negative infinity. And then lastly, as x approaches positive infinity, right, so our x is getting bigger and bigger and bigger, what is our y doing? And so as we're going this direction, what's happening right here? Well, it's going that direction as well, right? But not only is it going that direction, it's actually going closer and closer and closer to the x-axis. And so if we look at our table, we can see that our values for y get closer and closer and closer to the number 0. So that's what it's talking about, especially when it's referring to approaching something from the right-hand side or the left-hand side. So approaching from the left means I'm going this direction, and approaching from the right would mean I'm going this direction.